For Yugabyte CEO and co-founder Karthik Ranganathan, his love for technology started like most, with a video game. Those days of sitting in front of a device, button mashing, ignited a fire within him that only grew until he asked himself one obvious question: how do these things work? That question and an innate curiosity around technology carried him to stops at Microsoft and Facebook, ultimately leading him to Yugabyte. On today's episode of IT Visionaries, Karthik speaks about the evolution of the cloud, our growing need for our data to be closer to us, and how open source databases are becoming industry standard, meaning those that refuse to adapt are being left behind. Enjoy this episode. IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform. This podcast is created by the team at mission.org.
Welcome to another episode of IT Visionaries. I'm Ian Faison, host of IT Visionaries. And today we are joined by special guest, Karthik. What's going on?
Hey, Ian. Thank you for having me. Not much. I think interesting times with shelter in place, but other than that, things are going great.
Yeah, it is a crazy time indeed. Non-coincidentally, it's also a crazy time in the database world. So we're going to get deep into that today. We're going to talk about what you're building at Yugabyte and your background. So let's get into it. How did you get started in technology?
Okay, so my technology journey, I could tell you I am a very logical person, and I like mathematics and I like programming, and that's how I got into technology, but all of those would be a lie. I really started out playing computer games when I was young, so that was my actual foray into technology. But, pretty soon after that, I got intrigued by how these were built, and, it went one thing led to another. And before you know it, I'm in the world of technology. My actual paths through various companies started off like I did a couple of startups early on, was a part of them, and subsequently joined Microsoft working on the networking layer, the wireless and networking layer. It is a kind of a distributed system, but it's a very interesting set of technology, followed by my stint at Facebook, where I worked on distributed databases, and followed by distributed storage at Nutanix, and now here building a distributed SQL database at Yugabyte.
So flash forward to today. What does it mean to be the co-founder and CTO of Yugabyte?
Yeah, it's a lot of fun. I'll start with that. It can be fast-paced, it can be hectic, but it's definitely a lot of fun. So my role as one of the co-founders and the CTO, there's a lot of flexibility in the role, specifically in an earlier stage company such as ourselves, and it's true for every role. But I generally am responsible for the technical direction of the company. What are the technology we bet on? What do we think the market trends are going to be like, and really understanding them? What kind of messaging will really help end users understand the value we're bringing and the kind of problems that they can solve, both technical and business problems? And what do we expect these users and customers to be asking in the future in terms of product features or requirements or problems that they have to solve? And technology landscape moves really quickly nowadays. So how do we think it's going to change, and how can we stay relevant in the way people will consume us, and so on and so forth? And specifically, how all of the things that I mentioned applies to the world of databases and building applications. Another way to think about what Yugabyte is doing and how we all think about, it's not just me, it's everybody in the company thinks about, is we're all we all learn from our experiences. A number of us at Yugabyte have been at companies like Facebook and Google and LinkedIn and so on and so forth. These companies were born in the cloud and have really built massively engaging applications in the cloud for end users. And a bunch of us, myself included, have seen this transition of technology the technology stack, the infrastructure stack inside these companies start from a very simple stack to what you would call really cloud native, microservices oriented, geographically distributed, and so on and so forth, right? And so we've seen all of that happen at the big companies, and now we're seeing that happen at the enterprises at large in the world. And so we think we're in a great position to distill out the learnings from there, but build it in a way that the enterprises can consume them best.
Yeah. So, and before we were talking about this idea that, there's kind of different phases of the database. Can you walk through, like, for the listeners, what you mean by that and what the future could hold?
Absolutely. So if you think about the databases like about 20, 25 years ago that most people built applications on, it was invariably just one database, right? I mean, it was the time when application building for enterprises was like just getting steam. It was like becoming mainstream. And this would be databases like Oracle and SQL Server and DB2 and so on and so forth, right? These are the traditional relational SQL databases on a single node. Now, if you fast forward a bunch of years, maybe 10 or 15 years, you found that the internet kind of took off, right? So, and with the internet taking off, we found open source databases like MySQL and PostgreSQL started to take off. And like MySQL is famously a part of the LAMP stack, which is like Linux, Apache, the web server, MySQL, and PHP. And that powered a lot of websites, right? And so, and Postgres was similarly used in a number of places. And so these became the default databases for building internet scale applications. Now, if you fast forward a bunch of years, the mobile and JavaScript revolution happened. A lot of mobile apps came about. Like everybody had to build an app both for the desktop and the mobile. So at that point, you needed a database that would make it easy for developers of these applications to interact with. And MongoDB found its spot serving that sweet spot, right? Now, if you fall forward a few more years, you find that the cloud is really taking off, and it's at an inflection point where everybody is trying to move their application into the cloud. And the cloud really, what is the cloud, right? What does a cloud application have? It has some key properties, like you have high availability as a core property because the cloud is based off of commodity machines. It's what cuts the cost, right? It makes it cheap. But that means it also can fail anytime. So high availability and being resilient to failures is extremely important. Scale is the other big thing in the cloud. So no matter how many users you suddenly onboard, the cloud gives you enough capacity in just minutes, right? Not months. And before, where people used to have at most a couple of data centers, now you have about 200, right? So you can move your data really close to your user to give them a much better user experience. So all of these things get shrink wrapped into the cloud. And so now the world needs a new database and a new way of building applications for the cloud, right? And that's the spot that Yugabyte DB hopes to fill.
Yeah. So what is the crux of kind of like where the industry is at? Where are your customers at in their kind of, for lack of a better term, digital transformation or their journey or their cloud journey?
Yeah, this is a great question. And I can kind of walk you through what we saw through the 4 years of our journey as a company, right? In 2016, I remember and we're a very user and customer focused company. So we would have talked to hundreds and hundreds of customers about their use cases, their problems, what they're trying to achieve, and so on, right? So let's say we have a reasonable idea of what a bunch of customers we spoke to wanted. In 2016, most customers were not considering the cloud for their OLTP workloads, right? OLTP is online transaction processing, and which is the type of workload where you put user-facing applications and run those type of services. This is in stark contrast to a warehouse where you do analytics and you kind of get intelligence from what people have bought or how people are interacting with your product. Now, what we found is OLTP applications were not ready to move to the cloud in 2016. In 2017 and 18, they slowly started moving to the cloud, but it was mostly the test and dev or tier 2 kind of applications that were not super important, followed by mostly people taking whatever was running on premises and moving it into a VM in the cloud, right? Now, that's great, but that really doesn't get you your return on investment. It might actually make it more expensive sometimes because the cloud really offers a different set of features, right? Not the same as what you would if you're just running something on premise. Now, 2019 and this year, we see a massive surge to people actually redoing their applications to run in a cloud native way, right? And when we say we see a massive surge, we're still talking about the early adopters, right? There's still a large portion of the people that are slowly digitizing businesses, and digitizing a business is not a point in time, right? There's so many different applications and access patterns, and you need to digitize all of it, right? So what we find is people are moving to the cloud. People are increasingly understanding what the cloud gives, and that it all distills down to a few core patterns that they have to adopt, like a microservices-based design. What are you going to do to scale on demand? Because in reality, digitization means you build a lot of microservices and small applications without knowing which ones will take off and how much they will take off. So when they take off, it really takes off. Otherwise, it kind of tapers out slowly. So the problem is, if you put out a small piece of infrastructure because your app is not big enough and it really takes off, it's going to fail because it was so successful. It's like an accidental success. It was so successful, it failed. And if you put out a very large cluster, you cannot afford to keep spending that much money on apps that you don't know will or will not take off. So you're kind of stuck in this place where you have to start small, but grow quickly as you need it, right? So scale becomes extremely important, and the cloud really accentuates that. It really brings that, it makes it possible. And the third thing is people really getting their answers quickly, because a faster site, a website, getting answers quicker or better user engagement actually increases your revenue. And this is like multiple studies out there that tell you that. So the ability to deploy data in a way that you can move it close to the user becomes important. So we're starting to see people that are focusing on all of these. And some of the auxiliary things are like, how do they live in a world where some of their applications are on premises and some on one cloud and some on another cloud? So the hybrid cloud and multi-cloud world are also things we keep hearing over and over again.
Yeah, I mean, obviously, we hear that over and over again as well on this podcast. Are there things that you see that are kind of the the learning points or the issues that you see as people are kind of shifting in that environment?
Yes, yeah. Number of learnings, right? Like the first thing that people look for, high availability or resilience to faults, right, is kind of becomes table stakes. That's point number one, right? Like, so no matter whether your data set is large or small, what would become important is once this service becomes critical, you just want it to keep running all the time, right? It's one of the foundational pillars of a cloud native application. So that becomes something top of mind. And that doesn't just mean one portion of your stack. It's every piece. It's your applications, it's your database, et cetera, right? And it should be highly available in the sense that the failures should be of the order of a few seconds or less, like not a few minutes or hours, right? And invariably that means that you shouldn't have a human interacting in order to replace the system with a different system. So that's point number one. Point number two is that in a world where you are preparing to deploy at scale, whether it's one service or a lot of small services, either ways, it's still scale. Monitoring and alerting and like making sure that everything is running becomes extremely important. So you want your entire fleet to be always instrumented and always sending you data and being able to make sense of the data to make sure everything is running fine. So that's the second point. The third point that comes up is that you may be architecting for some scale today, but your scale is invariably going to grow by a factor of 10 at least in the coming years, right? So it's important to think through how you would scale out, scale up, scale out, whatever it is, how you would accommodate the larger workload. And there's a number of workloads where things shrink back. Like, let me give you an example. Like we have one of our customers, Narvar, they're in the retail business, right? And the last quarter of every year, the holiday months, right? They see a huge spike in their usage, right? Now they have to be prepared for it at every layer of their stack, all the way from the point that their ingress, like where the end user requests hit, to the place where they fan it out to their application servers, to their databases, etc. Right? Now, one of the things they explicitly thought through was that with every Cyber Monday, and I kid you not, every Cyber Monday is the new peak, right? It just keeps growing every year. So this last Cyber Monday on 2019 was the biggest shopping event ever, and that's a great thing. But what that means is it also is the day when you get the most requests on all your servers. So they used to joke that 6 months of the year you're preparing for this peak season, and the other 6 months of the year you don't want to touch anything, because you don't want to touch anything when there's a lot of traffic. So you pretty much don't do anything throughout the year, right? So
yeah, that's right.
Right. And so you need to break this paradigm somehow. So the way they did that was they thought through and they were evaluating what kind of a database and what kind of an application architecture should I put in so that I can quickly scale out, but also scale back down, right? You don't want to keep running at your new peak for the entire year because that represents many months of wasted revenue, right? For that money that you spend. So they just quickly scaled out Yugabyte, let it run for the peak season, and then they can scale it right back after, right? And that makes it very easy to do. And the cloud makes it very easy for you to acquire machines on demand and release them when you don't need it. So this is another transition that we're seeing quite a bit. Another point is the geographic distribution I talked about, and that's mostly related to people getting answers quicker. Like if you are serving a global audience, which a lot of digital companies end up doing over the course of developing applications for their users, a user in Europe or Asia is going to have extremely poor latencies and a very poor performance if you are keeping all your data in the US, right? So we did a number of such studies even at Facebook back then, and we kind of realized that we need to move data closer to users in order for users to get a better experience. Now, add to that all of the trust things going on around like compliance issues like GDPR, where every country wants you to keep the data of their users in that country. So there's a number of reasons why geographic distribution is becoming increasingly important as an architecture, both for applications and for data, right? So these are some of the things that people think about. We talked about running it in the cloud, right? There's also the aspect of building it. Now, with the cloud, like what used to happen back even at Facebook in the early days, I remember, was you would order your machines and then start building your application because, hey, it's going to take 8 months to 1 year anyway. So why sweat it? I can build mostly what I want in 8 months to 1 year, right? But now that 8 months to 1 year is a couple of minutes, right? And no one's going to build anything in a couple of minutes. So what really has changed is that now your development of features, your development of applications has to really accelerate because that is now the slowest point in the entire pipeline. So people are jumping towards CI/CD based deployments where you can like actually test your app and push it out and prod really quickly. So that brings us a whole new way of deploying, testing, and continuously releasing software, and all aspects, like database included, should be amenable to doing so.
What types of teams are you working with? Like who are your customers primarily?
Yeah, so I can name a few of them and then go through what they do and why they're using us, right? Like just give you a few examples of, and as a database, we're quite cross-cutting, so we can serve a number of verticals. So a vertical split is not that interesting in Yugabyte. However, like we talked about Narvar, they're a retail company. They are a retail post-purchase management and customer satisfaction platform. Like, for example, if you order something off of a website of any retailer, right, like a Home Depot or a Gap or a Macy's or what have you, then this product that you ordered has to be shipped to you. It needs tracking. You need to know where it is at any point. You need notifications at various points of time. And if you say you didn't like it and you wanted to return it, the same thing has to happen in the reverse direction, right? So Narvar takes care of all of that for companies like Home Depot, Gap, Macy's, Neiman Marcus, so on and so forth. So they have a 8-tier roster of all the retailers that they serve, and they help them really take care of customer satisfaction in these type of areas, right? Now, why they picked us or what they're doing with us is that some of their customers, they're currently running in AWS, and some of their customers want them to, customers often have demands on which cloud they prefer, right? So some of their customers want them to run or prefer the GCP cloud as their destination for where they would consume the Narvar service. So immediately Narvar now needs a multi-cloud database. Similarly, they also needed to figure out what they would do when the peak season hits. Like, for example, this entire COVID time, unexpectedly, is a peak season for retailers because everyone's ordering stuff online because you really cannot go to stores, or even if you do, it's going to be a very inefficient way to get stuff, right? You don't want to take the chance or the risk. So everybody's buying pattern increases online, which means people like Narvar and all of the online retail segments like would see a lot more traffic, right? And so you have to keep it scaled out, or maybe you have to scale out even further. So those are the use cases inside Narvar that Yugabyte is addressing, and it's all mostly critical data for Narvar. Another customer of ours is CipherTrace. It's a very interesting use case here. They are in the financial space, and they go ahead and get all the cryptocurrency transactions, like the Bitcoin transactions, so on and so forth, and they analyze those to figure out fraudulent behavior, to see if anybody is laundering money in the digital space, right? And they help law enforcement agencies catch the bad guys who launder money through cryptocurrency. And they need all of the transactions inside a scalable database because the set of transactions keeps growing all the time. And they need to run through it very quickly and in parallel figure out some patterns in real time and be able to report it. So that's CipherTrace. Another financial customer that's using us is XIgnite. Like if you've used like an app like Robinhood, right, to trade stocks, Robinhood shows you for different stocks what is the historical value of the stock, the current value of the stock, what does the graph look like, at what point should I sell it, and so on and so forth. That data is provided as an online API by XIgnite to power products like Robinhood, right? And the data that XIgnite stores, and that data gets stored in Yugabyte. And again, if you think about it, it's massive scale. It needs consistency. Like you could say, hey, my stock went from $5 to $10, but if there was a failure or an error and somehow you replayed the value as 5, it'll actually look like it went from 5 up to 10 and back to 5. And some people would sell their stock and be extremely unhappy because the real thing could be it went from 5 to 10 to 15 and they wanted to hold it, right? So you want your database to absolutely scale, absolutely be correct, and different people consume stocks in different places. You have stock agencies in different areas, so you want geographic distribution. So there's a number of things that keeps coming again and again because they would have SLAs to their customers and their customers would want them deployed in different clouds and so on and so forth, including on-premises and so on and so forth, right? So this just gives you some idea of a few different customers. There's a number of others, but it's distilling down to using the cloud better and building cloud-native applications.
And are you working with a CIO, a CTO? Like, who are the folks on the team that you're working with for this type of stuff?
It depends on the size of the company. It typically goes from CTO, CIO, slightly smaller companies to a cloud architect, to a VP of the platform division, line of businesses. So it just depends on the type of companies. And because of this whole transformation happening so quickly, different companies tend to organize themselves in slightly different ways. So there is a spread, but it's typically the people responsible for building a new app or an app initiative, like those people, and the people responsible for running it. So that would typically be the application architect or the cloud architect, that group, and the platform, the head of platform, or the people running the platform. So those two groups, right? Because they have slightly complementary functions. One has to build the app and get it out there to run, and the other has to keep it running and secure it and make sure it scales and so on and so forth.
Yeah, it's amazing. I mean, we talk a lot about on the show, how the different roles have been changing between CIO and CTO and everything. But it's amazing to see in practice who controls the database now, which part in the org does that, where does that fall, how does it change depending on the size of the organization and all that. It's just a fascinating microcosm in time.
That's true. And the change, I think what is interesting about the change is it's starting to accelerate, thanks to multiple different trends kind of converging at one point, right? You have the trend to go digital, like in itself, where people expect things online, expect it to scale, be highly available, yada, yada. You have the trend to utilize the cloud better, and that's for cost purposes because you can run things more efficiently if you don't have to run a data center in addition to running your business, because running a data center is not the core competence, right? And it's better left to somebody who can kind of get economies of scale across a number of companies. So that's the trend to the cloud is the second one. And then there's a third thing about actually using more data to do better decisions, right? Like all of the data-driven decision-making with respect and AI and ML and fraud detection, and all of this becomes an integral part of most of the applications people build online. Because as things shift online, you start hitting the next set of problems, which are around this data's proliferation, data security, data scale, and so on and so forth. So all of these coming together, things are rapidly changing.
Let's talk open source. So we had talked previously about the idea that open source is potentially a controversial topic. Where do you stand on the importance of open source?
Yeah, so we believe that open source is extremely is the way to go, especially in the database space. Now, I just say that open source as a requirement changes from technology field area to area. So I'm going to stick to data, databases, and fundamental infrastructure, right? That area where I believe open source is becoming pretty much the norm, or like the expected way to go, right? And of course, different people have their different points of view, and this just happens to be ours. But it's, it obviously has some rationale behind it, like we have our way of thinking. If you think about Linux before we even get to databases, right? Think about Linux. It started out with like there's no flavor of Linux that that is not fully open source. Now you can talk about, hey, why are like many flavors of Linux a particular license in open source called GPL, which is actually more restrictive than the more popular Apache 2.0 or the MIT license. But that has actually to do a lot with the behavior of people when open source first got introduced, right? So Linux actually is running ahead of databases in terms of its journey through the world of open source. And at that time, nobody would contribute to open source. And if something was free, people would just take it and run it, because the only kind of software was proprietary software. And in order to encourage the behavior of people to contribute back, this license, like the GPL license, was found. And what it said is, if you ever made an enhancement, you are forced, legally obliged to contribute it back, so people get familiar with that idea. Now, you fast forward 10 to 15 years, you find everybody's familiar with open source and everybody prefers open source, and people are okay with contributions, and they understand that you need to, like, if you're running a critical service, you probably need to pay a vendor to make sure it runs fine. While at the same time, having the code open means I can actually have an influence on it if I really start depending a lot on it, as opposed to waiting for the vendor to get back. And the vendor may have multiple competing priorities, and you may not be one of them, but your priority is important to you, and so on and so forth, right? So Linux went through this, and you would find no distro of Linux where any feature is held back as proprietary, like paid, and some features are open. That's not the case. The entire Linux is open. Red Hat is arguably the most phenomenal success in this area. And what Red Hat does is really takes an open source product, which is Linux, right? The Linux distribution, and makes it easy and turnkey for enterprises to consume, right? And that's really their value. So if you now apply the same thing to the world of databases, what you'd find is that today the fastest growing database is still PostgreSQL. And it is fully open. It is an Apache 2.0 license. It's the most open source database, or even one of the most open source pieces of software out there, right? And it's massively adopted and used, and is growing really fast. It's in fact the fastest growing database if you go look at DB Engine's ranking or anything. So now contrast that with a lot of vendors like MongoDB and a bunch of others, right, that are trying to go open core is the word, like where they keep some part of the database open and some part closed. And the part that's closed is typically the part you need in order to run an enterprise business in production. And now this was needed for a period of time because there was no other way to deliver software except getting the users to download it, run it, and operate it, right? And you'd probably give them support. Now, a lot of those vendors would say, I want your support. My use case is critical. They'd come and pay you. And a lot of others would say, you know what, it's not that critical, or I know how to do this myself. And you would feel like you didn't get the money that was owed to you because they're using your software. And at that point, you hold these features closed, right? Now, if you fast forward to the cloud era, people want to pay for hassle-free ability to run, especially when things will fail. That happens all the time. When things will have to scale, when you need to keep changing your hardware type, your software type. There's so many things going on that people don't really want to take on that burden, because it is not in the core competence of their company and their business if they really built out this ability, right? So at this point, what is becoming clear is that people want to be able to evaluate, run, analyze software without getting into a legal discussion on what happens down the road. Is it free? Is it not? Should I be dependent on one vendor? If the vendor starts charging way too much, cough, cough, Oracle. So if they start charging way too much, what do I do? Do I have a way to understand transparently what I'm paying for? I mean, I didn't make it up. I like Oracle as a database. They've done a great job, but I'm just saying it's what I hear all over. So yeah, so do I pay for it, or like what am I paying for? If I'm paying so much, maybe I just hire a team to work on these features, but those type of options get closed. So that's the reason why what we're seeing is that open source is really taking a foothold, and people going the other way are just temporarily trying to boost their revenue. But in the longer term, it's more short-term greed versus long-term greed, right? And we like to think we're long-term greedy, so we like to make more money over a longer period, giving everybody more value, right? So, and the cloud, whether it's a public or a private cloud, is really the way to monetize.
Well, so we talked to in a previous episode, which for our listeners who haven't checked it out, I highly recommend you do. The CIO of Juniper Networks was talking about like their journey to the cloud. So they're 100% cloud now. So Bob was saying basically it was super painful, but it's like we're going to put the mark on the wall and we're going to get there. And I just thought it was a really interesting look on like this like 7-year cloud journey that they kind of went through and everything and all the pain. But now he's at the point where he feels really good about everything. But it does bring up the point that you brought up, which is, okay, so what happens as the different clouds raise prices, change prices, all of that stuff, which now your business is 100% dependent on that. I'm just curious, like, what are your thoughts on how, CIOs can kind of navigate that?
No, I think this is a very important point, right? Like this is an extremely critical point, and the leverage lies in decentralizing your vendors for different things. I think that's the only practical way out. Like I'll actually even answer it with an analogy, right? Like I think 30 years ago, Oracle as a database took the decision of being independent of hardware. They were an independent company. They weren't builders of hardware. And back in that day, there were these RISC and CISC architectures for hardware, actual machines, right? Like, and you'd have the Intel side and you'd have the Sun Spark Solaris machines. And so there'd be different types of machines, and the users and customers would be, fragmented across these two type of fundamental architectures, which are different. Now, if each of the hardware vendors actually built a database and gave it to you, those would run really well. They'd do what you want. But when the time comes, specifically from the point that you're making as to if there becomes a dominant hardware vendor, or if one of them is shutting down business, God forbid, for whatever reason, because at the time, no one ever thought any of these lines would ever be discontinued because they were so strong, right, as companies and as products. Or like the price on one side goes way up, or the feature set goes down, or like for whatever reason, right, you had to change. You couldn't if you bought a database from one of these guys. And database is just one component. I think it's the overall stack, right? Like it's just good to have a few different cloud neutral or hardware neutral variants. So back in the day, it was hardware neutral. Now, if you now think of the cloud as the hardware of the old, where there, it's just got a lot more capability and a lot cheaper and better ROI and a lot more functionality built into it, then putting all the eggs in that basket will make the problem that you say much worse than it already is, right? The price fluctuations will hit you that much harder because it's not one product of the cloud that goes under the need to raise price. It's the cloud as a whole, right? That's typically how it works out. And even worse, like if you now add to it the fact that some clouds are hyper specialized in certain things, like for example, if you wanted, I don't know, like an Alexa-based platform, you probably want to use AWS because they manufacture Alexa. However, you want to use TensorFlow, then maybe Google's a better bet. Or I don't know, like there's different reasons why you'd go to different clouds, notwithstanding the big, AWS is a part of Amazon, which is also in the retail space. So maybe retailers want to rethink if they want to go to AWS or a different cloud, and a lot of them are. So like Walmart famously said so. So there's different reasons why you end up in different clouds. So that's one other point to note, like that you may have an affinity for different clouds at different points, because who knows how the dynamics of your choice have shifted with time. And the third and even more important point is that as a company grows and gets successful, and every company wants to do that, they probably are going to acquire smaller companies that add a lot of value. Like it's not worth every company building everything by themselves. And they could be operating on a different cloud. So whether you like it or not, a different cloud is in your mix, by one way or the other. So it is important for CIOs, CTOs, and the cloud architects to really think about a slightly longer term view. Obviously in the short term, you might have different priorities, different things would go through, but the slightly longer term view is an important one. And also rationalize that with the fact that everything is accelerating so fast that the long term may not be as long as we all think it is. Can't even believe 10 years ago there was no cloud, and today everything's cloud. And that shift has been dramatic, right? And if you look at projects like Kubernetes, which give you cloud independence, they have also had a meteoric rise and massive popularity, huge adoption. So it shows that people are thinking in those directions. And so it is important to think through what the strategy is and which pieces are the ones that would end up costing a lot or would end up being a huge architectural debt to move out of right in the future.
How do you think this is changed with things like AI and machine learning?
I think AI and machine learning have, if anything, added to the data scale demands or problem, depending on which side you sit. It's an opportunity for us, but for the person trying to cope with the data, it might be a challenge. I mean, essentially, what AI and machine learning do, if you just like distill it down, is real-time decision making based on data patterns, right? So that means the fundamental things you need a lot of data, because you need to write code or like get the AI and ML systems to analyze enough data to come up with patterns and train themselves. And then you need to continue collecting that data so that they can do the predictions for you. So this is just going to increase the data explosion on one side. On the other side, that is the raw material on which you work, right? Then there's the actual AI and ML algorithms, right? Like what they do. And those, I think, are also evolving over time. There's different frameworks, there's different ways to analyze data depending on what you want outside. Like you may want, like AI can be targeted to different areas, like it could be fraud detection, it could be speech and vision, and like image recognition. Like there's a different number of areas where you could point that to, and that just enables a net new set of digital applications to get built. So this is only going to increase, at least from the data perspective, the data challenge. From the database perspective, the set of features you need and the lower latency, higher performance type things. From the overall infrastructure perspective, this is going to increase the number of edge data centers you have. I mean, I'm going into a whole new area, but like with a lot of data, it's going to be difficult to keep transporting it to faraway locations. So you probably want to do your first order analysis close to where the data is being generated in many cases, and then send the analyzed data back to a central location for even further deeper analysis, right? So that kind of pattern seems to be on the rise. So there's a lot of changes that AI and ML are bringing, and it's bringing changes in each of the applications themselves. So not to mention different ways of different features now become a must-have.
Yeah, we just finished up a series on Edge, and the ramifications of what Edge brings to this is definitely extremely complex, and then throw in 5G as well. It's going to be really interesting times. Any other technology or things that you're particularly excited about?
Yeah, I actually am. Very excited about the rise of Kubernetes itself, which is infrastructure as code. It's obviously very close to the database area, but that's in itself like a very promising thing for people. Like, and that's because like I've seen how quickly a data center gets complicated at scale in places like Facebook, and why such technologies really make it simple. Although there is a definite maturity curve and a ecosystem building curve. But that's something that excites me a lot. The edge, I think we just briefly touched on it, but that I think has a lot of potential, because once again, the bandwidth between the devices and the edge is a lot more than the bandwidth you have from either of those two to the central location. So doing edge processing is great. And similarly, pushing back the data and things like remote surgery and like just new type of applications that will completely change our lives. And it's specifically very valid in these times, like for example, the shelter-in-place times. For example, we're slowly discovering that we need to do more and more, in a remote fashion and an online fashion, and so on and so forth. So that's another area that I'm super excited about.
You spent a bunch of time at Facebook. I'm curious, any just lessons from your time at Facebook and being an engineer there that you bring with you now as a CTO?
Oh yeah, a ton. Yeah, I just say like Facebook has been a phenomenal place to work and a lot of learnings for me. But I'll just try to distill a few things, right, that might be that'd be easy to call out. There's no means an exhaustive list. The first thing that I learned there intimately, and having worked as a database engineer throughout, is that building a database or a data system to cope with data and changing demands actually has its own life cycle. It's its own thing, its own living thing. So as the data size increases, as the access patterns change, as you start bringing in zones and other things and other types of hardware enhancements, your database and your data tier has to keep up. It has to constantly change and adapt and modify to the changes around it, right? So I find that very fascinating. Obviously, why I love working in this space, but that's something that's super complex, but super exciting and needs to be done in order to get true value for the end users without having to think about it. So that's one big takeaway for me. The second big takeaway is with respect to having fun while working hard, right? Like I fondly remember, like, most of the people at Yugabyte are actually people that, I had worked with before at Facebook. So we've all like shared experiences together. And contrary to how people might think about it, it's not just the fun experiences, but it's also being in the trenches at the difficult times. Like I remember, like, we were not only the team at Facebook that built the database features, we were also the team that operated it at scale. Now, obviously, that's helping us a lot in building this company, because operating a database in DBaaS is really important and critical, as we talked about in our point of view. But that is also a brutal job, in the sense you get paged at 3 a.m. when nobody wants to wake up, and you have to figure out what's going wrong with this database, or why is this customer not able to, or user not able to access his data. I have done that. A bunch of us have done that. But it was all done in a very positive way, and in ways where we reinforced each other and really had fun. And so that spirit kind of grew so strong that most of the team is back together building this database company at Yugabyte. So it's important to have play hard but have fun, like, and have the spirit of inquisitiveness and, like, the freedom to innovate at every layer and so on and so forth. So I think there's something to be said about that. Third takeaway, again, not related totally to technology, is about the openness aspect. Facebook was an incredibly open company. As much information as you needed, you could just go and get it at Facebook. No one would keep anything from you. And we've tried to follow a similar culture at Yugabyte. So we're extremely open with all our employees and with the world. In fact, we're an open source company, but specifically taking a really open posture. So that's another fond takeaway. And finally, last but not the least, there used to be a saying, the journey is only 1% done. It was a way of saying there's a lot more to be done. But if you flip it around, it really says, like, dream really big. That's another thing that we've all taken away. So.
Okay, let's get into our lightning round. These questions are fast and easy, just like Salesforce. The Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Go to salesforce.com/platform to learn more. They've been our sponsors from the very beginning. We love Salesforce and the Salesforce Customer 360 platform. Lightning round questions. Karthik, are you ready?
All right. Yeah.
#1, what app are you using on your phone that's the most fun?
Slack.
What is your favorite thing to cook or eat?
Pizza.
Do you have a favorite podcast or book that you've been particularly enjoying lately?
Recently, no. It's been pretty fragmented all over the place. Hacker News is the closest, but it's not a podcast or a book. So
yeah, that counts.
Okay.
How about a show that you've been binging?
I only recently started watching Breaking Bad, so that would be it. And Narcos is another. So don't judge me though.
No judgment. That's
Okay.
Breaking Bad's one of the all-time greats. What about your best advice for a first-time CTO?
Focus on getting the architecture right for the long term. I mean, it may seem a ways away, but it comes by pretty quickly.
What question do you never get asked that you wish you were asked more often?
I guess I don't get asked. I mean, enough people get asked this question, but it would be, what is the hardest part of building a business? And I'm going to answer it a slightly different way. I mean, the traditional right answer is actually finding product market fit, which is absolutely right. That's the right answer. But I'm going to answer it from a slightly different point of view. It is actually like in the entrepreneur world, it's juggling the number of threads you have to, right? Like it's like a ton of threads. It's not necessarily the depth in any one thread, which I was more used to as an engineer, but it's just the breadth and the number of threads.
Last question. We're in the middle of a crisis. I'm curious, any lessons or tips or anything that you all are doing that can help our listeners lead through times of crisis?
Yeah, a couple of things I can say. As a company, we're fortunate enough to be well positioned to work remotely, and we're hiring, so that might help some people. I would say that the set of tips I'd like to give most are staying connected with coworkers, with people is important. So we try to, like at Yugabyte, actually have a social online all hands kind of event where everybody gets online and just chit chats for a bit, like once a week. It's just like a half an hour, 45 minutes. But that kind of coming together and a break and like a little bit of socialization. That is extremely important. We found that like really effective. So that's on one side. On the other side, communication becomes key in these times, and it's not easy to communicate when you're not talking. So forcing yourselves to write a little more and like, be explicit, use those extra emoji when you're writing the comments, all of these start to matter, like, the finer points of communication. So, I mean, just a couple of tips.
Awesome. Karthik, that's all we got. That's it for today. Any final thoughts? Anything to plug?
No, I think this has been great overall, and I think final plug would be join our community at Yugabyte DB. It's open source, it's free. We are looking for enthusiastic people to become a part in building the next default SQL database for the cloud.
Awesome. Thanks so much, and take care. We'll talk soon.
Thanks for having me. Thank you.
IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform.